Okay, we're in section 27 of the notes, and we're talking about the SAGE, which computer algebra system. Again, you're more than welcome to go to the that magenta linked website and use the CoCalc instant instead. I haven't solved my computer. I would recommend, particularly for students at the level of Calc 2, that they should also install this on their computer as well. It just makes it a lot easier. And as you transfer to other schools, at least you'll have access on your computer. You won't need the internet. You'll be able to access SAGE at any point you want. So I'm going to do reset. Whoops, going to get my thing over here. Reset. I'm going to define t as a variable. Again, you did parametrics in math 120. And of course, it's just being repeated over here. And what's parametric is defined as x, a function of time, or t. And what is it? It's, let's take a look. It's 2 times t, right? That's done. And y is also being defined as a function of time. And what is it? It's 1 plus t to the 3/2. All right, what am I going to do now? I'm going to differentiate xt with respect to t. So I'm going to call that a new function. I'm going to call it dx. Function of t. What is it equal to? I'm going to differentiate the function x of t with respect to t. I'm going to say dy now. And what's dy? It's a new function. And it's going to be defined as a derivative of y of t with respect to t. All right. Now what are we going to do? Well, I'm going to integrate now. And again, this is where, you know, we're certainly in the area of calculus now. And I'm going to copy paste, by the way. And I'll talk about this being in the notes for you as well. And we'll look back over the notes. All right, so I just entered in, I get this over here. Now, if I want to approximate the number for that, I'm just going to say dot end. I'm going to ask it to approximate it. And approximate number there. What I want to do is I want to go back over the notes though, and I want to see if I see this problem. All right, I want to see if I see the problem. Now, again, for a lot of students looking back over something, I would have never thought about doing that. And you're right. A lot of people don't think about looking back in their careers, but you really want to try to, you know, gain some ground by looking back at what you've accomplished. And I think we've accomplished this problem over here. I'm just kind of looking around and I want to go through, we've done this one by hand. Again, you may have no recollection, and I'd be honest with you, the more problems you work, the less likely you're going to recall things. I will say this though, at Essex, 2 of the problems we give you are going to be almost identical to the problems that we're presenting to you in class, almost identical. All right. So again, I'm just scrolling back over this, kind of looking for it. Wouldn't it be awful if it wasn't there? And we're just scrolling back. That's all we're doing. The long section notes that we covered, right? Nope, I didn't see it. Let's go back over it again. Maybe I wasn't looking carefully enough. And I got to be more careful now looking, right? And I'm looking for x is equal to 2t. And part of this is to learn. You're learning, oh, look at it right here. We did this one, it's right here. What is this one over here? 2t is the function, you know, x of t, and this is the function of y of t, you know, 1 plus t to the 3/2. So I got that down. I entered it. What do we do over here? We went through the work. You know, I certainly did a lot with distance travel and stuff like that. But wonder what they're doing over here. It looks like what they're doing over here is they're doing some integration problem. Looks like they're doing like the, let's see what they are doing over there. Looks like you're doing the arc length, right? And did they do the arc length in that one over there? And I'll see if I did that. Yeah, right over here. I'm sorry, distance traveled. I'm sorry. The length of arc, yeah, but we called it distance traveled. And we just did this over here. That's all we did. All right. So let me just see if I plugged that in correctly for you. And I think I did symbolically. Did we get the same answer? 104 over 27 times square root of 13. Yeah, we got it. And the approximate answer we got is this over here. All right. So what you may decide to do, which I would encourage it, certainly someone says, well, I need to learn technology. Yeah, unfortunately, you need to learn technology. I shouldn't say unfortunately, it actually makes your lives easier. Maybe look back over these problems, see if you can code them. See if you can code these problems over here in the blue area and see if you're getting the same answers we're getting. All right. Should be relatively simple. All right. See, and by the way, you want to graph these things out, you can do that as well. All right. Thank you for paying attention.